Welcome back to our OEIS Deep Dive. You know, we love unearthing these hidden gems in the vast universe of integer sequences. Today, we're diving into sequence A000139. And, this one I think is going to be particularly interesting for number theory people out there.
Yeah, it's a really cool sequence.
Yeah.
It's a fantastic example of how a seemingly simple formula
Right.
can connect like all these different areas of math.
Okay, let's start with the formula itself.
Sure.
AN plus 1. I think I'm already seeing all those factorials. I'm getting a sense this sequence is going to grow pretty quickly.
Absolutely.
Yeah.
Factorials are a strong indication that we're dealing with combinatorial objects,
Right.
arrangements, structures, that kind of thing.
Yeah.
But it's the variety of objects this formula counts that makes it so intriguing.
Okay, unpack that for us a little bit.
Sure.
The OEIS entry mentions two-stack-sortable permutations.
Right. So we're talking algorithms here.
Precisely.
Okay. Imagine you have a stack of items, and you want to sort them using two additional stacks. But there are rules.
Okay.
A two-stack-sortable permutation is a valid arrangement you can achieve through this process.
So this sequence is telling us how many different ways we can sort using that two-stack method. Interesting, but it seems a little far from number theory.
Yeah, that's where it gets fascinating.
Okay.
This same sequence all counts rooted non-separable planar maps.
Okay.
These are ways to connect points on a plane, like a network, where removing any single connection splits the network into pieces.
Hold on. From sorting with stacks to networks on a plane, how can one formula count things that seem so different?
That's the beauty of this sequence.
Yeah.
It suggests a deeper mathematical structure connecting these seemingly unrelated concepts,
Right.
and it doesn't stop there.
Go on.
A000139 also counts the number of ways to dissect a square into smaller squares with n plus 1 vertices.
Wait, so if I take a square and try to divide it up into smaller squares, the number of ways I can do that is given by this sequence.
That's right.
Wow, okay, I'm starting to see how this one formula is like weaving together all these different mathematical ideas.
Exactly. And there's more.
Uh-huh.
This sequence also counts left ternary trees, a specific type of data structure. Each node has 3 branches.
Okay.
The number of possible trees with n nodes, again given by our formula.
Okay, now I'm really seeing the scope of this thing.
Yeah.
We've got algorithms, graph theory, data structures, all connected by this one formula.
It's pretty amazing.
It makes you wonder what the underlying connection is, the thing that ties these concepts together.
It's a question that has fascinated mathematicians for a long time.
Yeah.
And this is just the tip of the iceberg.
Oh, no.
A000139 has even more surprising connections.
Okay.
Things like fighting fish, those branching shapes, and specific arrangements of dominoes.
Dominoes, wow.
It's a sequence that keeps on giving.
This is already blowing my mind. We've got this formula. It connects all these different combinatorial objects.
Yeah.
But what about the formula itself? I mean, those factorials, they scream fast growth. But can we be more precise about how this sequence grows?
Absolutely.
Okay.
We can use Stirling's approximation to derive an asymptotic formula for A000139.
Okay. Stirling's approximation. Now that rings a bell.
Right.
From my number theory classes.
Exactly.
Yeah.
It's really helpful for understanding the behavior of sequences with factorials.
Right.
In this case, it tells us that A grows approximately like divided by a factor involving the square root of n and some additional terms.
So it's essentially exponential growth, but with a little bit of a break from that denominator.
Exactly. The A tells us the sequence grows roughly 6.5 times larger with each increase in n.
Right.
But the denominator refines that estimate and gives a more precise picture of the growth pattern.
So we've got the formula. We've got this incredible diversity of combinatorial connections.
Right.
And now we have a clearer sense of its growth pattern.
Yeah.
What else is there to uncover about this sequence?
Well, there's the fascinating world of generating functions.
Okay.
Ordinary, exponential, and even continued fraction forms,
Wow.
all associated with A000139.
Generating functions. They're like mathematical power tools for analyzing sequences, right?
Yeah, exactly.
Yeah. We might not have time to really delve into the specifics today,
Sure.
but it's exciting to know they exist for this sequence.
Right.
A000139. And speaking of connections,
Yes.
A00139 is also linked to other OEIS sequences,
Of course.
like A000142, which deals with Stirling numbers.
Right, those pop up everywhere in combinatorics.
Yeah, they do.
And then there's A001764, which counts ternary trees.
Bringing us back to those branching structures.
Full circle.
It's like we're exploring this vast interconnected web of mathematical ideas
Absolutely.
with A000139 as our guide.
That's a great way to put it. And who knows what other connections are out there just waiting to be discovered.
It really is amazing.
This sequence is a perfect example of how exploring the OEIS database
Right.
can lead to unexpected and fascinating mathematical journeys.
Absolutely. I couldn't agree more.
Yeah, it really highlights the power of this database.
It does.
It's not just a catalog of sequences, it's a tool for finding these hidden relationships.
Right?
And starting new mathematical investigations.
Absolutely. It makes you wonder, with all these connections, what practical applications might come out of understanding A000139 more deeply.
That's a great question.
Yeah,
And while some of these connections seem purely abstract,
right.
they do have implications for fields like computer science and network analysis.
Okay, like for instance, we talked about sorting algorithms earlier.
Right.
Efficient sorting, it's crucial in computer science.
Absolutely.
And understanding these two-stack-sortable permutations
Yeah.
could lead to new, more efficient sorting algorithms.
Precisely. And those rooted, non-separable planar maps,
Right.
think of them as models for robust networks,
Okay.
where the network stays connected even if one connection fails.
Right.
This is directly relevant to designing resilient infrastructure, like communication networks or transportation systems.
So we're seeing a potential bridge between theoretical combinatorics and real-world problem solving.
Exactly. And who knows what other applications are waiting to be discovered.
Right.
Perhaps there are connections to cryptography or coding theory areas where number theory is crucial.
This is what I find so exciting about the OEIS database.
Yeah.
It's a launch pad for exploring the unexpected ways math concepts can connect and influence each other.
Speaking of connections,
Yep.
the OEIS entry for A000139,
Right?
it doesn't just list those fascinating combinatorial interpretations.
Yeah.
It also provides links to research papers and books
Oh, cool.
that delve deeper into the math behind the sequence.
So for those listeners that want to go beyond our introductory dive here,
Absolutely.
those resources would be a great place to start.
A great starting point for further exploration.
Absolutely.
And as you delve into those sources, keep in mind the different interpretations we talked about today.
Right.
See if you can spot the common threads, the underlying mathematical structures that connect these seemingly different concepts.
It's like we've been given a map to a hidden treasure,
Yeah.
A000139.
Right.
And now we have the tools and the guidance to go on our own treasure hunt.
And who knows, maybe you'll uncover a new connection,
Yeah.
a new application, or even a new way of understanding this remarkable sequence.
Now, before we wrap up our exploration of A00139,
Right.
I think it's time to leave our listeners with a thought-provoking question.
I agree.
Something to ponder as they embark on their own mathematical journey.
We've seen how A00139 links to various areas of combinatorics.
Right,
But its roots are in number theory.
of course.
So here's a question for our number theory enthusiasts out there.
Okay?
Can you find a connection between A000139 and other number theory concepts you're studying?
That's a great challenge. Could there be a link to prime numbers?
Possibly.
Modular arithmetic?
Maybe.
Even Diophantine equations?
It's certainly worth exploring.
Yeah.
Remember, mathematics is a web of interconnected ideas.
Right.
What seems like a niche sequence today
Yeah.
might hold the key to unlocking new insights in seemingly unrelated areas tomorrow.
This has been a truly eye-opening deep dive into A000139.
It has.
We've journeyed from pancake sorting to planar maps,
Right.
from data structures to asymptotic formulas.
Yeah.
We even glimpsed at the vast potential applications hidden within this seemingly simple sequence.
And it's just one example of the countless mathematical treasures
Right.
waiting to be discovered within the OEIS database.
So to our listeners, we encourage you, don't be afraid to dive deep.
Yeah.
Explore the connections.
Absolutely.
And see where your own mathematical curiosity leads you.
You never know what fascinating discoveries await.
This has been great. I love this sequence.
Me too.
We hope you enjoyed this journey
Yes.
into the world of integer sequences,
It's fascinating.
and that you'll join us again for our next OEIS Deep Dive.
Please do.
Until then, keep exploring, keep questioning, and keep the spirit of mathematical discovery alive. It's been a really fun exploration.
Yeah, it has.
And I think our listeners now have like a whole new perspective on A000139
I hope so.
and all its surprising connections.
Yeah, it's a great example of how just one sequence can open up a world of mathematical inquiry.
Yeah.
You know, bridging different areas,
Yeah.
sparking new questions.
And for anyone that wants to dive even deeper,
Right.
the OEI entry is such a fantastic resource.
Oh, it's amazing.
It's like a roadmap for further exploration,
Absolutely.
with links to research papers, related sequences,
Right.
even historical context.
It really is a testament to the collaborative nature of math. You have mathematicians from all over the world
Right.
contributing to the OEIS, sharing their insights, and building this incredible repository of knowledge.
It's inspiring to think about this global community of mathematicians,
Yeah.
all connected by their fascination with numbers and patterns.
Yep.
And with tools like the OEIS,
Right.
we can all participate in this adventure of mathematical discovery,
Exactly.
regardless of background or level of expertise.
It's really amazing.
So to our listeners, we say, keep exploring,
Yes.
keep questioning.
Keep that spark of curiosity alive.
The world of math is vast and full of wonders.
It really is.
And the OEIS is a fantastic guide for navigating this exciting landscape.
Until next time.
Happy counting.